Now let's practice some geometric gradient series problems. So as a reminder, geometric gradient are a series of cash flows increasing or decreasing by a fixed percentage or rate at regular intervals. So let's write out this problem. Henry's going to put away $1,000 at the end of this year and is planning to increase this amount by 2% each year for the next 15 years. What is the present value of this series of savings if the interest rate is 8%? Okay, so what do we have here? Talking 15 years again. So we're starting at year 0 or now, and of course end of period convention says that we're going to start. A1 is $1,000, and the second payment is going to increase by 2%, or multiply that by 2%, etc., until we have some amount here in A15, which will be n minus 1, and this is in year 15. So in this case, we don't have a consistent amount every year because it's changing by a rate. We're going to have sort of a curved line here, and n is 15. This formula is a little more complicated. We don't have interest formulas to look up for this table, so we're going to have to do it the old-fashioned way and solve for p, filling in everything into the formula. So here's the formula. I'll write it out. 1 plus g to the n, 1 plus I to the negative n, and I minus g below here. Note, if I equals g, so if your interest rate is the same as your geometric increase, then p is going to equal a1 multiplied by n over 1 plus I. We don't have that in this case. So in this case, our g is 2%, our I is 8%. So we're going to fill this in. A1 is 1,000, 1 minus 1.02 to the 15, 1.08 to the minus 15. So it's pretty easy to make a mistake here. And when I multiply this whole factor out, well, I'll do it out for you, I guess. Let me make some more room on this piece of paper. Okay, so if I say 1 minus 1.02 to the 15, I'll put that in my Excel spreadsheet. And 1.02 to the 15 is 1.34587 by 1.08 to the minus 15, which is 0.31524. That's going to be all over 0.06. And then I end up getting 0 times 1 minus do the math here in Excel. 0.424 3 5757. And when I solve for this problem, I get 9595. So, the solution to this problem is that this series of increasing payments is equivalent to, in year 0, a P of 9595. Next problem. Henry's going to put away this amount. Same problem, increasing at 2%. What is the future value? Again, the same as the last set of problems. We're just going to convert F from P. So we had 9595 multiplied by 1 point. Interest rate is 8%, 15. And that gives us $30,438. That's the future value in year 15. And our last problem. Mary plans to start saving for a house after she finishes college in 2 years. She's going to put away $1,000 at the end of this year and is planning to increase it at a rate of 5%. So we essentially have the same problem as last time, except instead of a increase of 50 bucks and or a G amount, we're increasing by a rate. So we have 0, 1, 2. We're not going to start. It's not going to start happening until the end of year 2. And we're going to go till year 22. It's going to be some amount here that's going to increase at a rate of 5%. Interest rate is 8% and is 20. That will give us a value back to here. So our P at year 2 is going to be equal to A1, or 1,000, multiplied by 1 minus 1.05 to the 20, 1.08 to the minus 20, all over 0.08 minus 0.05. And that's going to give us a value of $14,358. Okay, but that's the value here at year 2. So we want to convert that to a present value in year 0. So we'll say P0 is equal to P2, 1 plus I to the 2. So 14,358 divided by 1.08 to the 2 is equivalent to $12,309.70.